Alright, good evening class. Let's go ahead and start filling this out. Make sure you put your name on it, today's date, which is the 21st. Okay, this will be due in class on Tuesday. I forget the exact date for Tuesday, but it's going to be the 25th. Okay, so we started on this lab today, Snickers Science. It is due next class period on the 25th. So the question is, can you use the Snickers candy bar to model the theory of plate tectonics? I'm pretty sure from what we did in class today that you guys would answer yes, right? So let's go ahead and do a little bit of background information. And to do this background information, we need to take a few notes, right? So on these notes, we have here that plate tectonics is the theory that the lithosphere is divided into these tectonic plates. These tectonic plates move around on top of what? Does anyone remember? It starts with an A. It's called the asthenosphere, which is just immediately below the lithosphere. Tectonic plate boundaries are divided into three types. I'm pretty sure by now you guys know all three types. One of them is going to be convergent. Another one is going to be the opposite of convergent, which is divergent. And the third and final one is transform. Okay. The type of boundary depends on how the tectonic plates move relative to one another. Tectonic plates can collide with, pull away from, or slide past each other. So if they collide with each other, they're going to be convergent. If they pull away from each other, they're going to be divergent. And if they slide past each other, they're going to be transform. One possible driving force of tectonic plate movement is the process of, does anyone remember what kind of currents we're talking about? It's going to be convection currents, like a convection oven, within the asthenosphere. The slow movement of the solid rock in the asthenosphere is caused by density changes. Density is the main factor that's affecting the plate tectonics. Density changes are caused by the outward flow of thermal energy. So the first blank is thermal, the second blank is energy. And thermal energy, when you think of thermal, I want you to think of temperature. So it has to do with heat from deep within the earth. When rock is heated, it starts to expand. Okay, so when rock is heated, if it starts to expand, is it going to be more dense or is it going to be less dense? So if it's expanding per unit area, it's going to be less dense. Okay, and when it's less dense, we know that more dense stuff starts to sink. So if it's less dense, it starts to rise to the surface. As it gets near the surface, the rock cools, and then when it starts to cool, it starts to become more dense, and then it starts to sink back down. This process of convection within the asthenosphere is believed to drive the tectonic plates above it to move relative to the convection currents below. So we used our Snickers bar, and we went through the procedure. Hopefully most of you guys washed your hands before touching your Snickers bar. Observe and open the end of the candy bar, which you guys did. And what you might not have done was draw a cross-section view of the candy bar and label it according to Earth's structural layers. Okay? Now when we're talking about a cross-section is if, for example, I was facing this way, okay, and you just cut my face in half, and then you would look at what is kind of the profile of my face, right? So when we were looking at our candy bars, we kind of tore them in half, and if you look at the inside of the Snickers bar, what you would see are different layers, okay? So some suggestions might be that the chocolate would be the lithosphere and the crust, okay? What would be the asthenosphere? What would be the core? Okay, so you're going to go ahead and label each of these. All right, you're going to draw it and you're going to label it. When you put your fingernail to break the crust, you are actually creating faults, okay? And this process is called just faulting, right? So on number 4, you were supposed to slowly and gently pull the edges of the candy bar away from each other. And if you pull them away from each other, this starts to create a divergent boundary. Divergent. Okay. And so what landforms occur at these divergent boundaries? Well, there's a few that I could mention, which are volcanoes and also fault block mountains. Now these mountains they're almost like cliff-like. That's why we're talking about block, okay? So volcanoes and fault block mountains, right? So over here on this part of your diagram, I would ask you to label the following items. So I would ask you to label volcanic mountains, fault block mountains, magma, rift zones, and I also want you to show arrows for movement. So go ahead and draw your candy bars moving apart. You would draw an arrow showing that they're moving apart. Alright, number 5, we're going to observe the candy bar, and we're going to redraw it and label it from a bird's eye view. That's pretty easy. Now, bird's eye view, Lionel was picking on another student. He was saying don't draw a bird's eye, like literally a bird's eye, but bird's eye view means that if you're looking at it from above, okay? Now we see here on question, or one of the first questions for number 6, okay? When we're pushing the plates, our Snickers bars back together, slowly and gently, horizontally, one half of the candy bar towards you, and the other half away from you, okay? What did this create? If one was going away from you and one was going towards you, this should be a transform, okay? What this creates is faulting and earthquakes. Kind of like San Andreas, right? What we were talking about before. In this box, I want you to label faults, the earthquake epicenter. And when you see epicenter, you see the word center, right? So that's kind of the origin of the earthquake. And again, in each of these boxes, I want you to show arrows for plate movement. Alright, now that we realign our plates so that they're together again, we're going to push on both ends of the candy bar to squeeze it together. And when we do that, what we're forming is a convergent boundary. So your convergent boundaries can be different depending on what kind of crust you're dealing with. If it's continental crust and continental crust, so I just put C and C, continental, continental, you are going to get mountains. If you're going to have continental and oceanic crust that are going to be convergent, what you're going to have is you're going to have the oceanic, which is more dense, and the continental, which is less dense. So remember, since the oceanic is more dense, it's going to start to sink, okay, while our continental kind of stays on top. So we have the process of subduction that's occurring. And as this crust is melting, it's turning into magma, and it's really, really hot, and it starts to climb up. And eventually, this magma is released out onto the crust, so we get volcanic mountains. Someone asked, is it just volcanic mountains, or can we get other things? And I think it wasn't just one person, I think it was a couple people. And yes, you could also get geysers. Or geysers. If you have oceanic and oceanic, you're going to get, again, volcanic mountains. Okay. In this fourth and final box, it is the fourth one, right? Fourth, yeah. So you're going to write out, let's see, the types of mountains that occur, okay? And you're also going to label the type of lithosphere crust. For example, carbon-carbon, or not carbon-carbon, excuse me, continental-continental, too much chemistry for me, continental-oceanic, and oceanic-oceanic. Okay. Now when you have continental-oceanic and oceanic-oceanic, you can have subduction that's occurring. So I'm going to put an asterisk by those because subduction can occur. Okay. Alright, let's see here. And again, redraw and label the candy bars based on the side view. And you have 1, 2, 3, 4, 5, 6, 7 questions that I want you guys to answer. Okay. State the theory of plate tectonics. What are the evidences of Earth to support the theory of plate tectonics? Can you use a Snickers bar? Explain how, why not, why is Earth's lithosphere considered a giant jigsaw puzzle? List and define the 3 types of tectonic plate boundaries. Rate of seafloor spreading problem. Let's look at this. So parts of Africa and South America were joined 135 million years ago. These parts are now 1,000 kilometers apart. What is the overall rate at which these parts are moving away from each other in millimeters per year? So it's a very simple division problem. So remember, look at your final units. Millimeters per year. That millimeters per year means that millimeters is going to be on the top of the fraction and year is going to be on the bottom of the fraction. Now here you don't have millimeters, you have kilometers. So you're going to have to do a little bit of conversion to get your millimeters per year. Alfred, and I'm not really very good with German, but I'm going to guess it's Wegener. If it turns out that sense and meaning are now becoming evident in the whole history of the Earth's development, why should we hesitate to toss the old views overboard? Explain why you think the acceptance of new ideas in science is a slow process. Now this is very open-ended, so take your time with it. Try to come up with good evidence for your claim. Okay. Best of luck. Hope you guys have an excellent weekend. I'll see you on Tuesday.